Okay, so let's speak about charge. Okay, about charge. First important thing is what is the symbol we are going to use for charge. For charge in physics, we are going to use letter Q. That Q can either be a capital Q or it could also be small q. So those are the symbols we are going to use for charge. Okay, either capital or small letter, it does not really make a change in this topic. You can use either one. That is the symbol for charge. Okay, now what is the unit in which charge is expressed? The international unit is the coulomb, and the symbol for coulomb is capital C. Okay, now in the book you will find most of the questions that they give you in nanocoulombs. How do you convert? You multiply by 10 to the minus 9 for nanocoulomb, for nano, any nano, and if it's a micro, then you multiply by 10 to the minus 6. Okay? Any question there? Now, as an important data, before this one you learn that charge can either be positive or negative. Charge can either be positive or negative, and you learned that one previously. Since grade 8, you already know and you start learning about charges. Okay? Now, what is the particle responsible for the charge of an object? What is the particle that is going to be responsible for an object to be either positive or negative? The electrons. The electrons are going to be the particles that is going to make objects to be either positive or negative. That is the number of electrons. Is that understood? So that is important thing. Now, when is an object going to be positive? When that object has less electrons than protons, of course. When is it going to be negative? When it has more electrons. How those electrons may move from one object to another? As soon as objects touch each other, electrons are going to transfer. So let's say, for instance, we have two spheres, because most of the work we're going to be doing here are with spheres. So we have one sphere, all right, and that sphere has a charge, hypothetically speaking. The charge of that sphere A is going to be equal to negative 5 coulombs. It means that charge has an excess of electrons. That charge, specific, have 5 coulombs because it has more electrons than protons already. All right? And we're going to make that charge to be in contact with another charge. Charge B. This one is A, that one is B. And let's say B is going to be having a charge of positive 3 coulombs. Okay, this one is charge B. Now what is important to know is that as soon as the objects touch each other, and I showed you yesterday with the simulation there, as soon as the balloon was touching that sweater, that jersey, you were laughing at that, electrons move to the balloon, isn't it? So as soon as you make these objects in contact, the electrons are going to be transferred from one to another. Remember, that is called a triboelectric charge. Okay? Now, in this case, where are the electrons going to move? From which one are they going to move? From A to B or from B to A? Well, you have to look to see who is more negative. A is more negative than B. It means it has much more electrons extra than does B have. So electrons are going to be transferred in this specific scenario from A to B. So electrons are going to move from A to B. They are transferred. Always the electrons will be transferred from the more negative to the more positive. Now, more negative does not mean that it's a negative number. For instance, 1 is more negative than 5. Both of them are positive, but 1 is more close to the negative side of the axis. It's closer to be negative. Is that understood? Yes. Because all this one we're going to speak about right now. So you know this part. That was no problem. Then from here, you went straight to the law of conservation of charge. So what that law state? We go here. This law states the net charge of an isolated system remain constant during any physical process. Guys, this one is going to be asked in the exam. For sure. So you learn because it's going to be there for 2 marks. Okay? But let's quickly have analysis of what is going on there. Net charge, what does it mean? What it means net? Because then the word net may be new for you. You see, it's new. So this one means total. Total charge. That means the word net. Net is total, not other thing than total. Isolated, you will learn eventually what is an isolated system in detail. But isolated means that it's close. That is isolated, it's close. So when we work with electrostatic, when I mean by isolated system, if we work with these two spheres A and B, which I'm going to redraw them here, this one is A and this one is B. This time I'm going to draw it apart. That is our system, only A and B. Nothing else is part of that. Maybe these are, let's say, on a ground, and they are hanging or on a stand, for instance. They are on stand. That stand is not part of our system. The system is a sphere A and B. That makes the system close. Only I'm bothered about the sphere. I don't care about the ground. I don't care about the stand. That is not part of the system. That makes the system to be isolated. Do you understand? So me, as the person who is studying the physics here, this question, I select the two spheres A and B are going to be my system. Anything else is going to be out of the system. There will be people working with those spheres, studying, but they are not part of the system. They are external factors. Yes. And then physical process is whatever happened to that sphere. It's like a physical thing that you can do to the sphere. Move them, change the color. That could be a physical process. You see? Or move them from this point to another point. That is a physical process. So that is for you to understand this law, to get an idea of what we're speaking about. All right, so now let's go to see in this sphere what is the law. How can we apply that law there? So as before, we're going to keep the same charges. So QA was minus 5 coulomb. QB was, I forgot, positive 3 coulombs. Okay, those are the charge. So let's go back to the law. What is the total charge here? Q total. That is what we call Q net. We use the symbol net like that. Okay, that is Q net. But in actual fact, it's not other thing than Q total. Let's calculate Q total there. Remember, the system is only the two spheres. That's why I say it's isolated. So in actual fact, I may remove all this one because I don't care about if they are standing like that or they are hanging from the roof. The only important thing here is the two spheres. So let's calculate the charge here. We have negative 5 plus 3 coulombs. It's the total. I have to calculate it. I have to add all of them to get the total amount. So the total charge here is going to be negative 2 coulomb. All right, and we're going to say that this one is before any physical process. I didn't do anything. I didn't change nothing there. Before any physical process. But now let's change a little bit. Let's take those two spheres and make them touch each other like we did before that. Okay, so that is going to be now a physical process. A physical process, they come in here, I'm going to take the two spheres, I'm going to keep them green. There is A here, this one is B. Alright? I'm not going to write the charges because they are on top and I didn't change anything. What is happening? We already spoke about them. What is going to happen here? Electrons are going to move from one of them to the other. So they're going to go from A to B. From A to B, electrons move. Do you understand? That is my physical process. The physical process is that touching of those sphere and making the electrons to move from one to another. That is the physical process. That is what happens during the physical process. So we can say here maybe just during, that is during the physical process. That is what is happening during the physical process. Now I'm going to take the two spheres and I'm going to separate them again. That is after the physical process. Okay? So I'm going to come here and I'm going to take the same two spheres and I'm going to separate it, the two of them. So I'm going to place A here once more. Maybe that is too small. That was A. You cannot see there. There we go. And then here is B. So this one is A and B. Process. This is after the physical process. What will the charge be? Not the same as before, because there were electrons moving from one to another. So the charge cannot be the same anymore. Now that is the part when the law says. The law says that during a physical process, during all this, from beginning to end, the total charge, which is net, must stay constant, isn't it? So to know that, what we have to do, we have to do a calculation here to get what is the new charge of each sphere. We say Q new for A and B. What is the new charge on A as well as the new charge in B? You say, is the charge of A plus the charge on B divided by 2. That will give you the new charge for A and B. Is that understood? So let's now substitute here. We have that is a minus 5 plus 3. So it's minus 5 plus 3 divided by 2. Is that correct? We go here and we get how much? Minus 2 divided by 2, that is minus 1. Minus 1 coulomb. What does it mean? That each sphere will have a charge of minus 1 coulomb after they were separated. So the charge A now, QA, is equal to minus 1 coulomb, and QB is also equal to minus 1 coulomb. Let's see what is the total charge after the separation. Because they say during any physical process, the total charges remain constant. So let's calculate here the total charge in this after the physical process. Q, no, I don't want to, yeah, that one is fine. Q net, which is Q total, is equal to QA plus QB. That correct? We have what we have? Minus 1 plus minus 1. Is that correct?
Yes, sir.
And what we get at the end? Negative 2 coulombs. Now let's compare with before and after. What is the total charge before? Negative 2 coulombs. You can see there. Before is negative 2 coulombs. After the process is negative 2 coulombs. There we go. So the total charge, the net one, remains constant during that physical process. Now with it also, you're supposed to go to charge quantization. Now the charge quantization is that the charge of any object is going to be the product of the elementary charge by the number of that elementary charge that object have either in excess or in deficit. It is not difficult. It sounds tricky and complicated, but it is not difficult. It's telling you that the charge of any object is going to be equal to the number of electrons that is called elementary charge multiplied by the charge of one electron. You say it's not that bad. This n stands by number of electrons. It's actually elementary charge. That is the number of electrons. This QE is the charge, this one here, is the charge of an electron. This one is what is constant. Is equal to minus 1,6 times 10 to the minus 19 coulombs. That is a constant which you are going to get. So with this formula, you can calculate what is the charge of an object after so many electrons were transferred. Did you understand? Or how many electrons are there to give a charge a specific value? For instance, if we come here to the 5 at the beginning of the question, here to this 5 there, and we use this formula of charge quantization, we know how many electrons this charge have in excess. How many extra electrons does it have to be a negative 5 coulomb? Is that understood? So if we come here, we say charge is equal to number of electrons multiplied by the charge of one electron. What is the charge? Negative 5 coulomb. It must be in coulomb. Charge must be in coulombs, huh? Equal to number of electrons multiplied by minus 1,6 times 10 to the minus 19 coulombs. You calculate, you rearrange this one. Number of electrons is equal to minus 5 divided by negative 1,6 times 10 to the minus 19. How much do you get for the number of electrons? 3,125 to the power positive 19. 19 electrons. So it means that sphere A has that number of electrons extra. That is why it is a negative 5 coulombs. That is not the total number of electrons. That is the number of electrons that give to A that specific charge. Did you understand?
Yes, sir.
So that is charge quantization. That is charge quantization. Now the only problem is when they ask you to calculate how many electrons were transferred from A to B. But that is for another day. That is for another day. I'll give you a chance to practice some questions with this. Now that is well explained, and then you will be sorted. That part of how many electrons are transferred from A to B, we'll speak about that one because it's going to be in the test as well. I'm going to ask.